Hey guys, today we're going to be talking about digital certificates. How are they used? What are they used for? And what's the difference between them and different authentication and encryption systems? A digital certificate is also known as public key certificate and is usually used to cryptographically link ownership of a specific public key with the entity that actually owns it. Digital certificates are used for sharing public keys in order to be implemented for encryption and authentication. Digital certificates usually include the public key being certified, identifying information about the entity that owns the public key, metadata related to the digital certificate, and also a digital signature of the public key that's being created by the issuer of the given certificate. If we're talking about distributing digital certificates and authentication, also revocation of such certificates, those are actually the primary purposes of the PKI, or so-called public key infrastructure, the system by which public keys are distributed and authenticated. Public key cryptography usually depends on specific key pairs. So we talked about public key cryptography, where we have private and public key, and here we're talking about same thing. Those certificates are just certifying that the person presenting a specific public key is the same that we thought. So they're certifying that you are the person that you're pretending to be, or the entity you're pretending to be. And those are third parties that are certifying this. Certified third parties that could be trusted, of course. So the PKI, or the public key cryptography, really depends on key pairs. One, a private key to be held by the owner, by and only the owner, and this key is used for signing and decrypting. And one public key, again, that can be used to encrypt data sent to the public key owner, or authentication of the certificate holder's signed data. So these are the things that we use different keys for, the two keys in the specific key pair. The digital certificate actually enables different entities to share their public key in a way that can be properly authenticated. Digital certificates are used in public key cryptography functions. They are most commonly used to initialize secure or SSL connections. Режеме и SSL connection, sad ще го кажа направо. Значи режеме от secure и сега ще кажа след това. SSL connections between web browsers and web servers. Digital certificates are also used in order to distribute and share keys in order to be used for public key encryption and authentication of different digital signatures. The digital certificate is used by all major web browsers. So we're talking about only the trusted third parties issuing the specific certificate, certifying that this key is owned by a specific entity. So all web browsers and web servers are using such certificates in order to provide assurance that published content has not been modified or any type of tampering has been conducted by unauthorized actors, malicious actors. We're talking about black hat hackers, etc. And this is also used to share keys for encrypting and decrypting web content. Digital certificates are also used in other contexts, of course. We're talking about both online and offline in order to provide cryptographic assurance and real privacy to data. Next step will be to understand who can issue a digital certificate. While it is possible for a specific entity to create its own PKI and really provision its own digital certificates, and actually in some cases this approach might be really reasonable. For example, in cases where specific organization maintains its own PKI in order to issue certificates for internal use only, and the vast majority of digital certificates are actually issued by Certificate Authority or CA. We're talking about certificates that are trusted by all different browsers, anywhere. So this also serves as a great convenience to users. CAs are considered trusted third parties in the context of PKI. Using a trusted third party to issue digital certificates is really beneficial, and it will allow individuals to extend their trust in the CA to the trustworthiness of the digital certificates that has been issued by it. Next thing that we're going to look at is difference between digital certificate and digital signature. Public key cryptography enables a number of different functions. That includes both encryption and proper authentication. A digital signature is another one of those functions actually enabled by public key cryptography. Those signatures are usually generated using algorithms specifically for signing of data, with the result that a recipient can absolutely confirm that the data was signed by the holder himself of a particular public key. Digital signatures are generally generated by hashing the data to be signed with a one-way cryptographic hash. Of course, we already talked about hashing and a one-way function. So the result is then encrypted with the signer's private key. The digital signature incorporates this encrypted hash, which can only be authenticated, or in other words, verified, by using the sender's public key. in order to decrypt the digital signature. And then, right afterwards, running the same one-way hashing algorithm on the content that was signed. If the two hashes are compared and they have a perfect match, that proves that the data was unchanged from the moment it was signed, and that the sender is actually the owner of the public key pair used to sign it. Generally, a digital signature can depend on the distribution of a public key in the form of a digital certificate. But we have a but here. It is not mandatory, definitely not mandatory, that the public key be transmitted in that form. However, digital certificates are usually signed digitally. That means that they should not be fully trusted unless the actual signature can be verified. Here we're going to look at next slide, which will be types of digital certificates. We can say that there are three different types of digital certificates usually used by different browsers, web servers, to authenticate over the internet. Those digital certificates are used to link a web server to a domain name, to the individual or organization that owns the domain. So link a web server for a domain to actual individual or organization that has the ownership of that specific domain. These certificates are usually referred to as SSL certificates. That's even though the SSL protocol has been actually suspended and now it moved to the transport layer security protocol, which is the TLS. This is the modern and most up-to-date version of SSL. It will be called TLS. Domain validated SSL certificates offer the least amount of assurance about the holder of the certificate. Applicants here for those DV SSL certificates need only to demonstrate that they have the right to use the specific domain name. While these certificates can give assurance that the data is being sent and received by the holder, the actual holder here of the certificate, in other words, they don't give no guarantees about who that actual entity is. So we can say that the domain validated SSL certificates are provide the least security level here. The organization validated SSL certificates, or the OVSSL certificates, provide additional assurances about the holder of the certificate, and that's in addition to confirming that the applicant has the right to use the domain. So those OVSSL certificates has applicants that undergo additional confirmation of their ownership of a specific domain name. The next one will be extended validation, or EV SSL certificates. Those are issued only after the applicant is able to prove their identity, and this is to the satisfaction of the certificate authority. The vetting process usually includes detailed verification of the existence of the entity that applies for the certificate, and also verification that the identity matches official records. That includes verifying that the specific entity is authorized to use the domain and confirming that the owner of the domain has authorized the issuance of such certificate. These types of SSL certificates are generally available for certificate authorities for web domains, though the exact method and criteria here is evolving as the certificate authority industry adapts to the new conditions and different applications. In addition to SSL certificates, there are other types of digital certificates which are used for different purposes. Those are as follows. Code signing certificates may be issued to organization of individuals. And here we'll go for listing. But we're talking about individuals who publish software. These certificates are actually used to share public keys that sign software code, including patches and different software updates. And also, code signing certificates certify the authenticity of the signed code repositories or libraries. So you see how the current development and software, mobile application, or just the increasing number of new cloud-based or mobile applications is driving the certificate authorities and the digital signatures, certificates, and all that to a new path, just opening new doors, new opportunities, which are taken little by little by the signing authorities. Client certificates are also called a digital ID, are actually issued to individuals in order to bind their identity to the public key in the certificate. Individuals can use these certificates in order to digitally sign messages or other types of data. Individuals can also use their private keys in order to encrypt data, and the data which basically recipients can decrypt using the given public key that's within the client certificate. So you see how complex, the same way, pretty straightforward process is used in order to give us additional security when working with different cryptographic techniques and systems. You can play a little bit, try to issue your own certificate, work with open source or just free certificates online. Komodo is a good source for that. Understand those and be sure that you're going to be encountering them in a everyday basis while working as a cybersecurity expert, or in this case, a penetration tester. Thanks for watching, guys. Stay tuned with our next video.